Okay, great. Can you all hear me okay? In the back? I know we've got mics in the room as well, so hopefully the sound will be good. I know that we have people who are remote as well. I have put up some slides here. I guess first off, I should introduce. My name is Paco Nathan, and this course here is Entity Resolved Knowledge Graphs. So we'll be talking about using entity resolution for data quality, data preparation, and then knowledge graph construction downstream from that, and some of the implications. This is a project that came out of a collaboration between Neo4j and Sensing. So obviously Neo4j very much in the knowledge graph space, and Sensing very much in the entity resolution space. And I'm from another company. I'm from a company called Darwin. We do integration, and the other companies approached us and wanted to see if we could help show how to do some open source integration for what they were working on together. And just a little bit in terms of some of the administrative parts, all the slides are online, and if you want, you can get the slides on your mobile or whatever if you scan the QR code, or there's just a shortened URL there as well, but it's under Darwin. So all the slides are there. We also have a GitHub repo, which goes along with this, which has the notebooks. In the interest of time and whatnot, there's also some of the intermediate results that have been stored, and they're available on the cloud for a download. Part of the thing I'm curious about is, this tutorial here, it takes about an hour if you want to run it on your own, probably less than an hour, really depending on what sort of system resources you have. But I'm aware that people are on a lot of different types of systems here. You have different laptops. Some of you may have cloud resources that you use. And I know like people who are remote also may be running Zoom. If you have an IDE that you're using and you're using something like Zoom, that's already a pretty large memory footprint. This here will chew up some memory. And of course, if you're running like Neo4j desktop, what I'm saying is I'm concerned that some of the types of environments people are in might have a really strong memory requirement too much. And so even though this tutorial, you could blast through it in less than an hour, we've got an hour and a half here, and I want to make sure that people are getting questions answered. So the way I've organized this is, really all of it is available online. You could run through it. I'm going to go through it and talk about how it works and give some supplemental information, and obviously, Q&A. But also, I've tried to provide different waypoints along this tutorial so that if you don't have time to run everything, you don't have the resources for whatever reason, you could pick up at some point and move forward. And so having said that, and all the materials will be linked off of right here, this QR code, and we'll get into it. So the main gist of what we're going to cover is, what if you start out with some data sources? Some of them are structured, some of them are semi-structured. In this case, we've got data that's coming from a company called SafeGraph. Anybody here ever worked with SafeGraph data before? Just curious. I actually worked with them, gosh, over a decade ago, back when Hadoop was a new thing, and I was out teaching courses of hands-on work with Hadoop. I worked with an earlier precursor of SafeGraph. They produce a data set called Places of Interest, and so worldwide, they have a lot of geospatial data about places and businesses, addresses, that kind of thing. And it's very rich. There's a lot of attributes for all the different records. What we've done is to narrow down. So we're just taking a look at businesses in the Las Vegas metro area. And that gives us, we filtered out a few things, but generally speaking, once we put it all together, we'll have about 100,000 records from different data sources. And we wanted to try to keep it under the 100,000 threshold for a few reasons. A lot of it is just because of memory management and what kind of time do we have to get through in a tutorial. The fact is, like with Sensing, it's got a 200 millisecond SLA. So if you can do something with 100,000 records, you can probably do some 100 million records. But basically, we start out with some semi-structured data from SafeGraph, And we add to that, there's the WISCART data set that comes out of the Department of Labor. And so that's a federal open source data in the US. And it basically looks at employers throughout the US and where have there been wage compliance violations or audits or some kind of follow-up. So it's a lot of employment information throughout the US. And so that's coming directly off the Department of Labor. And then there's PPP, which is from the US Bureau Chamber of Commerce, Small Business Administration Chamber of Commerce. The PPP data is history about companies that have taken PPP loans during the pandemic, and then subsequent to that, some other metadata they've collected. So we have these three semi-structured data sources, and they're all looking at businesses in the Las Vegas area. And what we're going to do is build a knowledge graph out of that. But one of the key problems is that there are slight differences in the names, in the addresses. Some of the records are wrong. If it's government data, there's probably some bad data in there, right? And boy, have I been through that. I had one business years ago, and the IRS fined us massively, and they finally tracked it down to they were having this problem, and they had a tape that was a backup, and somebody kept reloading it and had bad data. So they'd send us a fine, and then they couldn't figure out why they'd find us, and we go through months of dialogue, and eventually they realized that somebody was just restoring backups they weren't supposed to. So if it's government data, there's probably bad data. What we're going to do is use entity resolution off of a library from Senzing. We'll be using this to go and resolve what are the businesses, who are the names, how do they match up, who are individuals in this area that are also related, what are the addresses, and I'll show some examples. But the thing is, if a business is located at 101 Main Street and their address is recorded in a database as 101 Main space ST dot, okay, that's one representation. What if they spell out street the entire way? What if they drop the dot? What if they actually accidentally put in 1001 because somebody did a typo when they're keying it in? There's all kinds of things like this that happen in practice. And so you end up with business names, with people's names, with addresses especially, but also other types of identifier record, whether you're talking about transportation like vehicles that you're tracking, trucks or ships or that kind of thing. So there can be a lot of problems with just minor data quality that throws everything off. And you could say, hey, if I go in and I look at this data and do some analysis just on the surface, it's got about 2% error rate as far as duplicates. Now there may be some other areas, other classes of errors in there too, but this is about 2%. This is about 98% correct. And you could say, okay, 98% data, yeah, that's pretty good for open data. We should celebrate that. The reality, though, is if we're talking about business addresses and something needs to happen that's crucial, like your taxes, or if it's the police department in Las Vegas and they're deploying a SWAT team because there's been a kidnapping and they have a 2% false positive rate, boy, they're going to hear about it. So there are a lot of these kind of cases where just even minor errors are going to cause a problem. And certainly you want to be reducing your false positives for a lot of reasons. So Senzing is very good at that, at being able to resolve these kinds of little nuances, especially in addresses, especially in names, but in other types of data as well. Being able to apply an ensemble of different machine learning models internally and do that resolution of, I've got 50 different entities that are kind of close. Some of them are probably the same person. Others are probably differentiated. So if you have Bob Smith, but then you have Bob Smith Jr., Bob Smith Sr., Bob Smith III, Bob R. Smith, you also have business or address data about them. How do you try to figure out which are actual individuals and which should be distinct? That's a big problem. So we're going to cover how to go through and do the entity resolution, how this works, also how you can drill down and get evidence and do audits and understand the provenance trail for that. And then from there, we're going to take the same data and start to organize it, basically building out the relations. And so we'll be using Neo at this point, and you can kind of see just as a guide, you start out with like 100,000 records, they're all disjoint. You start tying them together, you begin to get a graph. And then from there, you can drill down and get a lot more information and start to do some inference or other kinds of downstream use cases with the graph. So it's really these four categories are the outline for the tutorial. And I should say, if the past 15 years or any guidance, I love doing live tutorials. This is the first one I've done in a few years because of the pandemic. I think at this point, I've probably had about 10,000 people go through my live classes over the past 15 years. So I did a lot with Spark and Ray and a lot of courses about Spacey and graph work with KG Lab and others. I know that there's going to be some setup here, so I'm going to try to guide you through. If you want to do the entire end-to-end tutorial from scratch, I think it's feasible within the time, and I'll guide you through it. It will depend on what kind of environment you have. If you want to watch me go through the tutorial and maybe do this when you're at home and you have more resources in front of you, that's also an option. All of this is online. But having done a lot of tutorials in the past, I know that this one has some moving parts to it. There's some sophisticated parts. So I just wanted to give that caveat that we're trying to cover for a lot of different environments that you may have. And so having said that, if you want to do the full end-to-end tutorial, starting from scratch, you'll need to fire up some sort of a Linux server to be running the sensing API. So I'm going to show using it in Ubuntu or Debian, and there's images if you're using Red Hat or other flavors of Linux as well. And yeah, question.
So, Sarah, is this, you mentioned something about open source. Is this an open source project?
Yeah. So all the components I'm going to show here are open source. They also have some commercial versions of it, the larger scale. Sensing, the code is open. The models, you can use up to 100K records with a free license. But once you start getting in larger spaces, then you need a commercial license. But the code itself is open. And so the core code is in C++, but there's a Python wrapper, which is the most popular. And I'll show everything in Python. That's a good point. Any other questions starting out? Yeah.
I don't think this will run on a Mac data.
Well, you could do some work to get the API running on a Mac. Like you could run it in Docker. If you're comfortable running containers on your laptop, that's an option too. You can run the whole API out of that. I'm going to show the Python API and a little bit of coding and sensing from like a POC level, just because I think it's better. It's less. How can I put this? Pedagogically, it's better to understand what the interaction is with the API. If you wanted to do this in production, you'd probably be using a container and wiring up a little bit differently. But I've tried to approach this from the standpoint of, if you've never used this code before, you want to be able to observe what's going on. So this part here will be in Linux. The rest of this, though, I will be showing Neo4j off of Neo4j desktop. And so, if you've got a Mac, if you've got a Windows, you can run that. If you don't have a Linux laptop, a cheap thing to do is just fire up a cloud server, a Linux box in the cloud. And seriously, what we're doing will cost about 4 cents if you're on Google or Amazon or Azure or one of those. Or if you have other Linux resources and you want to fire something up, that's great. If you already have Neo4j, like your company uses it, you have access to all kinds of Neo4j, I'm sure this will translate quite well. I'm just going to show it in desktop for people who are new to this, but I think what we're doing should translate. We'll show using the Graph Data Science library, the GDS library in Python that Neo's come out with. It's very nice, and it fits really well with a project that I've been doing called KG Lab, which is very similar kind of library, but over in the RDF side of the world. So there are some parts that'll need some installations, and I'll cover those real quick if you want to get started on those installations. I don't know what the download environment here is. I'm hoping it's pretty good. The pipes look pretty good. I've been measuring a little bit, but if you want to go and do the full end-to-end thing, definitely if you don't have Neo4j installed, there's the desktop version. It's probably the easiest thing to do. And there's a link here for neo4j.com/download, and then you can get into doing the desktop part of it. And I'll show how to configure, but the download is the big part. And the other thing is, I'm going to bounce around a little bit just to start this out. But if you don't have a Linux box that you can just log into and run things, then you may want to set up a cloud instance. And I'm going to show using Ubuntu, but you don't have to. You could use some other flavor like Red Hat. The main caveat is you want a box that has at least 16 gig of memory. Memory is a real requirement. I'm going to show it configured for like 4 cores, so 4 virtual CPUs or more, but really make sure you have enough memory. There's some other downloads that'll be required. We'll be working with these data sets, and there's a page where you can go to get them. And I'm going to bounce around the slides, but my best advice is to go ahead and download the slides. It's the URL. If you haven't downloaded them yet, if you just hit the initial QR code that I showed, I can go back to that. And it has links for everything you download. But we'll need to download the data sets. There are 3 of these: SafeGraph, Department of Labor, and Small Business Admin. They're all zip files. They'll come down, and then there's some JSON inside. And the other download should be pretty quick. It's from GitHub, but we put together, I'll flip over to it. So we have an open source repo, a public repo that shows this whole tutorial. And in particular, it's got some notebooks that go through the different steps that we'll be going through. So if you don't want to be running this hands-on and you just want to see how it all lines up, how it all works, you can check out these notebooks as well. I've checked them in so that they have all of their output preserved, and it tries to run through things as best as possible. But we will, in the course, we will be downloading this repo and working from it. So let me just go real quick and put this back up. Gramble. If you don't have these slides yet, definitely get them. And then there'll be links to everything else you need to download. And while those downloads are in progress, I'll continue on with the rest of the lecture and give some background. Sound good? Anybody else need to keep this up for a while? Okay, great. Okay, so let me give some introduction. And the first thing is, this is a Knowledge Graph conference. Probably this question here is a bit too general, but you know, in this context here, knowledge graphs provide very flexible, structured representation of connected data. They enable a lot of really advanced work in terms of analytics and discovery and search, visualization, various forms of inference, etc. And this would be difficult to obtain if you have connected data, if you weren't using knowledge graph. In the sense here, I think the thing that we'll really try to bring out is graphs, surface, and contextualize relationships. A lot of the data warehouse kind of work with relational data, it's a lot about fact tables and understanding aggregations and summarizations and looking at numbers week over week and all that. Graphs, though, they really surface the relationships and the richness of the relationship between the entities and the data. What that means, though, is you really need to be able to determine what are your entities and what are your relationships. And so a lot of what we're doing here is to be able to formalize the data quality for developing the entities before we bring it into a graph. The other side of it, though, is, of course, graphs have become very popular for contemporary use of AI, things like using retrieval augmented generation to ground the data for LLMs. And so now we're seeing a lot of graph plus RAG kinds of applications. And actually the next series in this tutorial, that's what we're doing is instead of Vegas, we're doing London and then doing a graph RAG example with it. Okay, next question though is what is entity resolution? And this is a bit more nuanced. I'll do another slide to compare and contrast, but here what we're talking about is the ability to match data in different records and to determine the relationships based on identity. So if you have records from 3 different data sets and some of them appear to be overlapping, how can we try to establish which are actual duplicates of each other or which provide evidence for somebody to come in and drill down and take a deeper look at it? And as I mentioned, duplicate entries are one of the big things to fight. It can be a real problem in data quality. It's a real problem in graphs, because if you are constructing a graph out of some data sources and you have a lot of duplicates, what that's going to do is water down your ability to make inference off the graph. So if you have, again, Bob Smith, but you have 5 different instances of Bob Smith, And now you've got a knowledge graph where you've loaded up 5 different nodes representing Bob Smith. And the things that are crucial to annotate about Bob Smith have been split in 5 different ways. If you go and try to use that in like a LLM, you're going to be getting some fairly poor quality data downstream. That's the main thing we're trying to bring home. And of course, if you're at large scale, where you're working with hundreds of millions of entities, this becomes a much, much bigger problem. So, yeah.
I've heard technical resolution before mostly context of natural language processing.
That's my next slide.
So here you are taking a binary definition.
Right. Well, that's actually my next slide.
Okay.
So there's some name collision there. There's entity resolution. There's another thing that you'll hear a lot about, entity linking, which is a very interesting thing to do with knowledge graphs. There's something else called named entity recognition. And a lot of academic papers make a typo and they'll talk about named entity resolution, which is not the right term. So there's been a lot of confusion between them. But these are 3 different things. And so on that point, actually, let me just go down to that slide. A friend of mine took a pass through, Doug Fields took a pass through this earlier on, and he actually recommended moving this slide up in advance. So I will. There we go. Yeah. So I do a lot of work in natural language. It's a lot of my background. In fact, that's how I got into graphs, was doing text graph work. In natural language, we have something called named entity recognition, NER, and it's very powerful. What this means with NER is that you've taken some unstructured data, some text, and you've parsed it, and now you have a stream of parsed tokens. And so with NER, what you want to do is identify spans of those tokens which represent different noun phrases. And then you want to apply labeling on those noun phrases to assign them to different classes. So if you're using something like Spacey, the defaults in NLP with Spacey will come out with like, here's a person's name, here's a city, here's a nationality, here's a date, here's a monetary measure, things like that. But again, it's unstructured data applying labels to have classes. Entity resolution is based off of using structured or semi-structured data and looking at the values in the columns and seeing how they align. And so rather than labeling it, what you're doing is literally trying to do essentially unique identifiers, taking free text that's inside of some structured data and then developing unique identifiers out of that. And it's probably as good a time as any to show the next slide. This was my talk a few years ago at KGC, but there was a project we had called Bridge Context, doing some work in federal government and also in German government. If you're building a knowledge graph and you have unique identifiers, persistent identifiers, like DOIs that are used for articles, academic papers, or like ORCID is used for researchers. How many people here have an ORCID ID? Probably, yeah, like a third of us, right? ISBNs for books, ISSNs for magazines, RORs are being used for organizations, W3ID for web pages. I could go on, but there's these different classes of unique identifiers. But when you get to listings of businesses, listings of people, there's not really a formal sense for identifiers. Maybe based off of tax codes, you could have like an EIN would represent some corporation. Or a SSN would represent some individual. But then you get into problems. Are you really going to populate your knowledge graph with SSNs? Because now you might be tripping over some data privacy issues. So entity resolution then is a way of trying to address this in structured or semi-structured data by developing unique identifiers for people and for businesses, their addresses, et cetera. This same kind of approach has been used in other areas too. It's been applied, for instance, for tracking identifiers for maritime vehicles. Other types of applications in industry where you need some sort of unique identifier, but nothing really exists as a standard yet. So, any other questions along those lines? Great question, by the way. Okay. So if we take these two concepts then, what's a knowledge graph, what's entity resolution, and put them together, what we're trying to show is this idea of an entity resolved knowledge graph. One of the ways you can look at entity resolution is you could just throw everything into a graph and then run resolution there. And you may actually have a lot of really good signals to work with. And in some use cases, that's how it's done. If you're working with really crucial data like addresses, tax records, these kind of things, it's generally a better idea in terms of scale and performance to be doing that resolution before it goes into the graph, because once it's in the graph, it's going to be a lot more expensive. So what we're showing is to have this as a stage coming off of your data integration, doing your entity resolution, and then from there propagating that information down into your graph construction. There's another reason for this is what if you get hit with compliance? Like you get hit with a takedown notice, privacy notice, or maybe there's some crucial information that needs to be updated. In this kind of scenario, where the entity resolution is done in advance, you can go in, make those updates, you can audit, drill down, get a lot of information about what's the supporting evidence for decisions that have been made previously, but now need to be redacted. And then it'll propagate downstream, it'll update how those entities are being resolved. So in the sense of responding to compliance issues or responding to audits, having the entity resolution broke out as a stage before you do your knowledge graph construction, it works out to be a much faster way to handle things at scale once you're in production. So we're using this term ERKGs, that's the title for the tutorial, of just being able to put these two kinds of practices together. And I wanted to just give a little bit of background. There's a good paper here from Lise Couture. This is 2012, so this is 12 years ago, but just talking about the difficulties with entity resolution. It can be a very challenging kind of problem. And there have been some really great materials recently. I'll shout out to a couple colleagues, but Melanie Ritchie out of Marigold Analytics had a great talk that she gave keynote last year in DC at the Sensing User Conference. This is fairly brief, very concise, but one of my favorite talks lately. So I definitely recommend Mel's talk. And then another colleague of mine, Ben Lorca, did an article about this earlier. Actually, it was almost a year ago, out of Gradient Flow. And he broke down what are some of the factors of consideration of entity resolution in practice in the industry. So this is not exactly a white paper, it's more of an article, but kind of bridging toward a white paper. But Ben went into explaining a lot of the principles of what's going on. Highly recommended. And then there's also some resources on sensing. There's a number of different articles that are probably good background, but I'm also linking out to this article that we did on the Neo4j blog. We ran this last month. And it's basically a lot of this tutorial, but in article format, explained out in text. So if you want, this is also a pretty good resource to fall back on if you want to check through. And we've got a lot of links to primary sources and all the libraries, et cetera, in here. Okay. Let's see. All right. Any questions so far? Yeah.
Question. Is the approach you're describing good enough yet to handle property names or individual names that are represented by different character sets?
Oh, interesting. Yeah, there's been a lot of work in character sets. Yeah. And actually, I mean, a lot of this work came out of actually some of the folks in the room here, but it came out of IBM a long time ago. And they've been handling a lot of it, especially internationally. That's a big problem. And so, yeah, they have a lot of background there. And because you can imagine just even going back and forth between UTF and EPSTIC and all this, you get into some pretty interesting edge cases. But definitely going through different countries, you run into that as well. So I know that that's been a big thing. I'm trying to think of some examples. One of the components inside of Sensing is their own customization of libpostal. And I know they've done a lot of work on the internationalization, having libpostal++. So that would be like one example. Other questions? Okay, great. All right. So first thing is with Neo4j. Well, I want to show Neo4j desktop. Again, this is the download. There's more instructions to get set up on desktop. Once you've done the download, you'll need to have an activation key, which you can get for free. But it's on the second link. If you go through there, if you run through, once you're doing the download, there's a link you can click that'll give you a text blurb that has your activation key. And then this describes once you launch desktop on your laptop, then you'll go through and well, you launch the application. Once it's launched, you provide an activation key. And I believe it's up in the upper right corner. Just cut and paste the key. And once you've got that started, you should see something very much like this. And let me get through these points. Okay, so this is my instance of Neo4j desktop running. And right here, I've got a project called Entity Resolution. That doesn't really have a lot of bearing in terms of the tutorial. You just need to give it some kind of name. Let's see here. Okay, so the project name is Entity Resolution. That's a setting that we use. It's not really needed for the credentials though. Once you've set up a project then, and I'll show this in a moment, you need to create a database. And in this tutorial, I'm calling the database Sensing. Again, that's one of our settings. It's needed, but not really using the credentials. You will have to give it a database name. And this is actually something that's kind of buried in the docs, but the default database name is Neo4j. That's the default, and we won't change it, but that is required for the credentials later. You also have to provide a username. The default one is Neo4j, and we won't change that. We'll just use it. You will have to specify a password, and we generated a random password here to use a consistent one throughout the tutorial. You can use whatever password you want, but I highlight this because you'll have to go through and either set or use each one of these. So when you're getting started with Neo4j, the first thing is it'll ask you to set up a new project. Yes. So I've created a project that I call Entity Resolution. And inside of here, let me step through the points. I'm going to create a database inside of my project in Neo4j. So I click the Add button up at the top and select Local DBMS. And I will just call this tutorial. I'll call this KGC. And it will prompt you for a password and also which version to use. I'm just going to cut and paste this. And cut and paste. Let me take a look. Okay. All right. I think this is probably a pretty small font size, so let me boost it up. Is that readable yet? Can you see that okay? Okay. So I'm going to take a look at my env right there. Okay. I've got an env file where I'm just keeping all my credentials, and I'll use this later on in the software. But right there, I've got password, NeoPass is USI, et cetera, the randomly generated one. So I'm going to create a new database here. I'm going to give it this password. And then I'm going to select version 5.8. There's actually later. There's 5.19 just came out. I'm just going to keep with the 5.18 I was using before. But you click Create, and that'll go through and start to build out a database for you. The next thing you want to do is to go to the plugins over on the right. And let me see. This thing has to really start up first. There we go. Okay, so we've got KGC tutorial. This is a database we just activated. We'll go to plugins, and we're going to go down to the second one. There's one called Graph Data Science Library. That's the plugin to support the GDS library we'll use. You just have to click this open and hit install. It'll take a few seconds, and it should get you set up with GDS. Okay, great. And then from that point, we can come back over here to the KGC tutorial database and click Start. Take a little bit, but it'll just launch it. Once it launches, it'll tell us what ports we're using, which is the other part of the information we need. And there's some defaults. I don't expect too. Oh, you know what? Let me make sure I've stopped everything else. Yeah, okay, good. This will take a few moments. Yeah, and it'll probably come out and tell you, if you've got some conflicts on port numbers. We're not going to be using these services off of Neo4j desktop. There's a discovery service, there's the RAP clustering service, et cetera. We don't really care, so we don't really need to worry about these. But what this will give us, we should have started our database, and it should show you some details. Okay, great. So we've got this KGC tutorial and it's starting up and should come back okay. We've got on 5.18 and it should be serving here shortly. And so I'll keep this application running in the background and we'll hit it through a service, through essentially it's HTTP, but we'll be using the Bolt connector and hitting it through the service that it shows us. So now you can see over on the right-hand side under details, we've got the KGC tutorial database going, and Neo4j is the DBMS. We've got the password that we added. We've got the Neo4j default user. But more importantly, over here, it's telling us that the IP address it's using localhost, and it's got a Bolt port is 7687. And so you'll need that data. That should be the default. But we'll use this in a moment to create our credentials. But okay, we're good to go here. Let me cut back over to, all right. So we've got these credentials set up. Next thing we do, okay, we've run through all of this, start button. At this point, we're good to go with Neo4j and our GDS library should be able to work. If you want to drill down and get more information, the GDS library is relatively recent. I really like it. It blends really well with the PyData stack. So if you're familiar with using like Pandas, MATLAB, Matplotlib, Seaborn, just all the rest and sort of your typical NumPy-ish based PyData stack, what GDS will do is once you run a Cypher query, it'll give you back a Pandas data frame for your results. So you can start to do some chaining onto that. So if you're familiar with typical data science tools, GDS blends in with it very, very nicely. And there's more background. We won't really need it, but the API is all online if you want to get more information about GDS. Okay. The next step is let's get the public repo. And so there's this repo on GitHub, and it's under Darwin AI ERKG. Let me bring it up. Okay, and let me zoom this a little bit so it's a little bit easier to read. So if you go to this URL, github/darwinai/ERKG, you've got a public repo and there's the green code button. If you click that, you can copy this URL. And then once you go over into a terminal window, actually, let me do a new one. I'll go someplace. Get, clone, and paste. So if you say get and then clone and then give the URL that you need, it'll initiate a download. I'm gonna start this and then kill it, but should be a few seconds. But go ahead and load that up in wherever you're going to be working on your laptop. Okay, I've got it loaded up here. And so inside of here, we've got the data, we've got the notebooks. There's a few examples. There's a README that just describes exactly what's shown on the GitHub page. The main steps to get started on this, though, cut back. Okay, so the main steps is once you've got the repo, I'm going to show using Python 3.11. A lot of the recent Python 3x should work with this just fine, but we've been using 3.11 a lot lately. So I'll show this with 3.11. If you have 3.9 or 3.10 or whatever, that should be fine, 3.12, etc. What I'm going to do is create a virtual environment, and then I'll activate, basically begin using that virtual environment in Python. And then from there, I'm going to just update pip and wheel, just so I have the latest tools, and then use the requirements from this repo, do a pip install -r requirements.txt. So just showing that real quick. If I go, I'm going to go in a different directory. KG. Okay, so I've got a recently cloned repo here. And the first thing I'm going to do is say Python 3, actually just to show you that, yeah, it's 3.11. We'll say Python 3 and then -m, venv, and I'm going to give it a directory, venv. So I'll create my virtual environment. Once you've got that, then you can say source, BNV, bin, activate. And now everything else that you install will be put under this directory structure. So if you add new libraries, they will just be contained here within this virtual environment. And a thing that I usually like to do when I'm working in Python, one of the first things is to do pip-m install. I'll get the latest is a cap U, and I'll say, give me the latest pip and the latest wheel. Sorry. Pip. Okay. So if you say Python 3-m pip install, -u means give you the latest. I want to get the latest pip and the latest wheel. That way I have the best tools. And in fact, yeah, there was an older pip there. Okay. Once I've got that, then I can say Python 3-m pip install, and I'll do R requirements. What this is going to do is just load up the requirements that we have specified. I can show those. So we're using Jupyter to show parts of this. We're using Neo4j, Graph Data Science. We'll make use of Seaborn, PyViz, and a few others, but it's not a lot of requirements. Should be pretty quick. Okay. And then once we've got this set up, then we can just go over to Jupyter and do the rest of the work out of Jupyter. All right. Any troubles with installs? This is okay for people who are doing it? Okay, good. Keep me honest.
You said the notebook is somewhere?
Yeah, the notebooks are all in the repo, the GitHub repo. And so let me switch over. If you go to the GitHub repo, it's right here. And then notebooks are under examples. And yeah, so we're going to take a look at these in order. We've got datasets.ipynb. The dataset analysis is the first one. Then we'll go and do a graph construction, and then we'll do some analysis, some graph analytics and visualization, looking at the impact. And then the actual impact, the analysis comes out as these two files here. Big Vegas 2 and .html is the one particularly that we'll be producing at the end. Okay, so when I take a look here back on what I was just running, all this is installed. We should be good to go. So we've downloaded the repo and we've got everything set up. And we can leave this for a moment. We'll come back to it in just a bit. But now we want to go, next slide. I want to take the credentials to be able to access Neo4j. So I've got these 4 points. I've got where the private endpoint, the local service, is for both. So that's going to be localhost :7687. And the DBMS by default, that's Neo4j. The user name by default is Neo4j, and then the password is the one that we supplied. So whatever credential you're using, you want to put those into a file. We'll call it a .env, and it's inside of this directory. Just to make things quicker, I'm going to copy these. So I've got source arkg.env. I'll copy it locally, and then we'll take a look. Okay, so I've got these 4 different environment variables: Neo4j bolts, Neo4j DBMS, user, pass, and then I've got the credential values for them. And I'm going to be using a local Python library. I'll be using something that's called python.env, and it'll just load these automatically into environment variables. Yeah.
Neo4j that we are using it for storing the data which needs to be the resolution needs to be done. So on top of it, the Python library that we are going to use it for navigating through the data. Is that the way that things that I can understand?
Kind of more side by side. So we're going to be running Neo4j in the background. It's basically running as a service, and it has a database. It can manage multiple databases at the same time, but it's running off in the background. There's a connector called Bolt, which is HTTP, and it's running on the 7687 port. And so anytime that we need to access the database, we'll just make a call through the Bolt protocol using that service port. And so that's going to run in the background. We're going to be running all of our examples in Jupyter. And so just out of the notebook, we'll run Python code, the GDS code, and at times it will call back over to the database.
So the Neo4j is essentially the what a fact file pandas do, is it?
That's a really good point. Yeah. So here we're working with connected data, and you want to have some place to be able to store what you're developing, because we're doing this iteratively. We start out with approximately 100,000 records, a little bit less, but they're from 3 data sets. And we're going to add a lot of analysis and then layer on some relations on top of that. So we're collecting all these different parts iteratively, and we're just going to keep inserting them into Neo4j and have that collected. And then at the end, you'll end up with that connected knowledge graph.
So for the way to structure report exercises.
Yeah.
It's like pandas for the fact file, the same way that graph data that I'm trying to store it in the Neo4j, and then trying to solve my end objective. That's how I can.
Yeah, that's a good way. With one nuance, when you're interacting with Neo4j, most of what we'll show here is using a query language called Cypher. So we have Cypher queries to be able to do some type of retrieval. And the idea there is the query is an expression of different subgraphs. You're doing some algebra, query algebra, et cetera, to be able to access different parts of your knowledge graph. What it returns, though, is essentially a table. And so what happens then is, instead of storing everything in pandas, we're storing it in Neo4j. We send a query over, and it returns back a table. And so then that is represented as a data frame, any results going on. And then what we're going to do is some downstream processing. So we'll chain onto there. We get the result set. We do some other work, and eventually come out with a result. So it's just basically building a pipeline. Yeah.
My question is more on compatibility. So Neo4j, as we know, is a labeled property graph.
Right.
But does the sensing work with the RDF triple store?
That's a great question. So what sensing is doing is here. Let me cut back. What sensing is doing is really operating on the data records, and then maintaining internally. There's a temporary graph that it's building to be able to do the resolution. So it has its own sort of temporary. They might be entities, they might not. Here's the evidence that's applied to it, and then they make decisions. That all happens internally. What it exposes, though, is it's going to basically give us some JSON output that says, here's an entity, and it is linked to the following records. Or here's an entity, we don't have a record for it, but we think it might have a high probability, here's the probability, of being connected to this other entity. Maybe you should just take a look. Does that make sense?
Sure. Yeah.
So basically, there'll be some ETL that will get all of this JSON coming out of sensing, and that can be running as a microservice, like I say, just on a Linux box. And then the rest of that consumes and sticks the results in Neo.
And that JSON can be fed to any other triple store or data graph.
Exactly, you could, yeah. Here we're working with Neo4j because there's a lot of properties that come out, and it seems really interesting to be able to collect those and be able to do something. And so in later tutorials, we'll be showing a lot more leverage of the property graph. And there's some other reasons too. It's just Neo has a lot of benefits here. But if you wanted to, you could be building up other triples, because what's coming out of sensing are essentially entities or nodes. And then there are relations between entities. Your records are also nodes. So if you have evidence to support the construction of an entity, then you have a relation to all the supporting records. That's a kind of triple, each one of those. If you have some inferred relationships between entities, that's a different type of triple. So if you wanted to, you could do an RDF as well. It would be more data. It would be probably less efficient as far as storage. That's a great question. Any other questions, Ray? Yeah. Yeah.
I didn't know where you got those
Yeah, these credentials, this is basically the same credentials we use when we set up the Neo4j database. If you're using your own Neo4j and you already have credentials, just plug those in instead. But the 4 ones that we need will be what's the service endpoint, and then also the name of the database, and the user and the password. Yeah, question?
Just go once more back to Neo4j for the configuration of the database. How to do it exactly, because I'm not able to enter a user name.
Oh,
Maybe I did something wrong.
no, you're right. I struggled with that. When I was building this, I went through the docs and I went to one of the people who helped write the docs. And I was like, where? And he was like, oh yeah. So yeah, that's actually something that's kind of hidden. There's a default value for username.
Yeah.
If you're using desktop, it's probably best just to keep with the default. If you're doing something in production or you're using
Yeah.
like a cloud instance, your people will have.
And it's not asked in the desktop query. So it's not asked even to enter a username. It's just a DBMS and a password.
Exactly, that I could not find a way to do
And
it.
even not the database.
Yeah, I asked and so, yeah, that's a good point. Any other questions about that? Okay. There is a way to do it, but you have to dig in quite a bit. It's not, yeah. All right, so the next part here, let's see, we've got these 3 data sets, and I want to show, if you go to this URL, there's a landing page. Let me boost the font on it so it's a little bit more readable. But we've got 3 downloads. So there's a SafeGraph one, there's a zip file that comes out of this. And then there's the Department of Labor Wizard one, also a zip file download. And then there's the PPP loans. These are all zip files. Download them, and you'll end up with, I believe they all come out either as JSON or CSV. And let me show that. I've actually downloaded these already, and I've got them over on KGC. I've got them in a directory. I downloaded them and I just changed their names. I mentioned that on the slide, but I'm just going to call them POI as places of interest. I'll use that throughout the tutorial. That's from SafeGraph. DOL, Department of Labor, is the WizGuard one, and then PPP is the one about loans. So what I'm going to do is just create that directory over here under this repo. I'll say McDear LD data. Come on, dear, I should know Unix better. And then I'm going to go back and just copy all these 3 into LV data. And then if I push down, okay. So if I take a look at these, I've got JSON records basically at this point. And you'll see that each one of them has a data source and a record ID. So this is some metadata that we've added just to make sure that as we're processing these files through Sensing, that we keep track of each record uniquely. But otherwise, it's just all the fields that come out of these open data sets. Here with SafeGraph, this is their places of interest. If you take a look, SafeGraph is, I don't want that one. SafeGraph data site is interesting. They have these products they provide. They're making this for Las Vegas. They're making it open for us. But they have a lot more metadata about what's inside, what's really available. We're working with the places data set. So they have a lot more detail here if you really want to go in and drill down on that. But it's basically, it comes down to what do we have in this JSON file. And so you can see that there are things like location name org, brands, top category, NICS codes, on and on. There's a lot of business information. Also latitude and longitude. The main things that we're going to be worried about are what are the names and the addresses. That's really what we'll be using on the business data. And then there's the Department of Labor has this data. It's actually a lot, each record is actually a lot larger. Again, we have a data source, it's DOL WizGuard, and we just use that to keep track. But in here, you've got names of businesses, you've got what is their legal name versus the DBA they're operating under, you've got what is their addresses broken out, line 1, line 2, etc. You also have information about how many employees they have, how many violations they've been cited for as far as wage compliance. A lot of the other interesting information about employees that would be difficult to get otherwise. One of the interesting things here, though, is if you haven't seen it before, US government, in terms of census, has a thing called NAICS, which is a kind of categorization of different business types. And it's used by Patent and Trade, it's used by DoD, et cetera. So basically, you can think of that as a kind of taxonomy for businesses. And so it's nice. They've got these codes broken out. So we could actually leverage that. We're not going to do it in this tutorial, but we could leverage this data and build out more connections in our knowledge graph based off of NACS. That would be a nice follow-up to this tutorial. There are a few other things that come out of the Department of Labor information as well that could be used to add additional relationships. We won't go into just yet. Okay, and then there's one more data set. It's called PPP. And so this comes out of Small Business Administration. And it's got, again, you see the data source and the record ID. Those are things that's kind of unique to identify. But it's got information about PPP loans during the pandemic. So it'll tell you like the range of the loan that was taken, has a business name, business address again. It also has NACS codes. That's interesting. You can start to link stuff in. It has more detail about what type of business. Is it an LLC? Is it a Chapter C, that kind of thing. And then also more about, is it owned by a veteran? Is it a nonprofit? On and on and on. A little bit of banking information, et cetera. So we can start to pull together another picture about a business based off the PPP information. But basically, if you do the download, sorry. If you do the downloads here, you'll end up with these files. It's talking about CSVs. They're actually all JSONs now, if I recall. They were originally sourced from some CSV files, but they'll be organized, essentially they'll be organized as a text file that has a JSON record on each line. Formally speaking, that's a JSON-L file, but we'll be reading it in that kind of format. So once you've got these downloaded, what I recommend is renaming them with these short names so you don't have to retype it all over. But again, just call it poi.json, dol.json, and ppp.json. Okay. All right, now if we come up, I want to be moving along because we have limited time. I want to at least start showing some exploration on these data, what are in these data sets. So I'm going to run Jupyter to be able to explore this. The way to launch is if we go back to the repo that we downloaded, where we've set up the virtual environment. I will just run Jupyter out of that environment, and it will give me a new service, localhost 8888, and then I'll look at each of the different notebooks, these 3 notebooks. So first one here, I will say env in Jupyter lab. So Jupyter Space Lab or Jupyter Lab, either way will work. This should automatically launch a new tab into your browser. And if it doesn't, you can just go to localhost 8888. Let me boost the font size a little bit. Okay, so this will give me, now I've got, here's the data I was just looking at. Got those 3 data sets. And then here's the, here's the example notebooks right here. So click on the examples folder. And first off, we'll launch one called datasets. And I can probably make this a little bit bigger. All right, is this readable in the back? Or I can boost the font size if not. Is it good? Okay, good. All right, so here we'll just take a quick look at the data sets. In the interest of time, I kind of want to blast through, but a lot of this is shown. We set up what are the libraries we're going to import. So mostly we're using GDS, Graph Data Science, but there's a few others. I like to throw in a watermark. If you haven't worked with notebooks before, watermark is a nice library because it'll show you what you have installed, what versions, what dependencies you're using. So if you need to troubleshoot on your libraries, basically here's what I've used. It's a snapshot of my environment. And then the data sets here, I'm going to define, this first set here defines a real simple function called sampledf. Basically, we're going to take a data frame that has loaded up a file with a lot of different fields in it, and we're just going to specify certain fields that we want to take a look at, just so we can analyze them more. So I will take this whole clear outputs. Okay. So I'll start from 0. I'll run this first cell, and I will have loaded my libraries. Should just take a few seconds here. And yeah, good. Once I've got that, I can just run watermark. It's optional. It just shows you what your versions are. I'm going to define this method just to be able to work with data frames more fluidly. But what it does is it takes a data frame and it says, give me a copy of the data frame and drop the columns that I don't want. So that way I can do analysis just on specific columns. Once I've got that defined, now I've got here, I'm going to set up a path for places of interest, poi.json. So you can see it's on that subdirectory lb_data. What we're going to do is read from this. Basically, this is a comprehension in Python. What we're saying is we're going to read each line out of this file. And then for each line, we're going to take that and load it into JSON as a dictionary. And so now I'm going to end up with a list of dictionaries. And then I'm going to build a pandas data frame from a list of dictionaries. If you haven't worked with pandas much before, this is actually one of the most efficient ways to load a data frame. There are other ways that seem more straightforward, but take an abysmal amount of time. So I like to do this. And then, let's see here. I'm also going to save off a name just for sake of my sanity, rather than having to type out location name org. I want to have a consistent column called name for these 3 data sets. So I'll just copy the column over. Boom. And this should be pretty quick. Let's take a look at the head. So we'll just take a look at the first few records. You can see here, data source, safe graph, record ID, org type, et cetera. But now we get into some interesting things. Here's name and address information, phone number, et cetera, for all these businesses around Las Vegas. I want to take a look at a few records. There's actually a lot of different columns in this, as you can see. I don't need all of this. So I'm just going to take a look at a few to get some ideas. So like name, category, lat long, all that. And if we take a look at the first few records, and you can see you have these. Category, that's interesting. That might give me some nice structure for the knowledge graph later on. So I'm going to do a df describe, data frame describe, and that'll do statistics about the values that are in these specific columns. Okay, and so it shows you that I've got record ID is completely unique. I've got fully populated unique values. It shows me that I have 388 subcategories. So I could actually build up a taxonomy here that would be kind of interesting. And I do not have uniqueness when it comes to latitude and longitude. There's a lot of overlap there. Also business addresses. If you look at that, there's also overlap. There's 32,000 unique addresses out of 80,000 records. So this is already giving me some interesting analytics about this data. There's definitely some overlap. Okay, and I'll just crunch through this real quick, but for the other 2 data sets, here's the wizard from the Department of Labor. We'll load that. Again, we'll just pull out a few columns we're going to look at. And you can see you've got address, name, violation count is kind of interesting. And if I look here, I have this uniqueness property for the record IDs. If I look at the actual names, though, there's certainly some overlap. And addresses also, there's some overlap. And then in the PPP data set, similarly, you can see here, we've got a lot of different columns in this one. But I'm just going to pull out about the number of jobs reported, business type, et cetera. Okay, so I've got, again, business name and address. And you can see uniqueness holds for the record IDs, but there's overlap in terms of addresses, also in terms of names. Okay, so those are the 3 data sets we're working with. And now the next step is we're going to use the credentials we provided before and load up GDS. So now this is connected. It's talking with the graph database, talking with Neo. Yeah.
I have an error when trying to load the POI, the first one.
Yeah.
It's an encoding or some string error. I don't know if others.
What kind of error do you have?
Because there's a string error.
I think it's because it's a zip file. You have to unzip it to get the JSON.
Very good point. Yeah.
You did unzip it?
Is it so? When you get the zip out, is it a JSON file that comes out of it?
Yep.
I'll come around and look. Okay, yeah. Is anybody else getting that too? Any errors on loading the? Is it the POI file?
The first one.
Yeah, first one.
The second one was nice.
Okay.
No problem.
There may have been something corrupted on the zip. I don't think so. Usually it's pretty good with error correction.
Oh,
but
yeah, it looks good as well when I open it on a.
Okay, we have like a half hour left, so I'm gonna move fast through some of this just to be able to show it. So basically, inside of our graph database, I'm going to create a record node key constraint. I'm gonna say, I've got a unique identifier for every record, and I want to make sure that when you're loading it up, make sure that there's no overlap. I don't have duplicate records accidentally. So that's what these here, I'm basically gonna drop my prior ones and just create that constraint in Neo. And then I've got a few methods here, which we're gonna use in Python to be able to convert from what we have as a pandas data frame to be able to load those up into Neo as basically creating our nodes. So one of the things we're going to do is just some data cleaning really, but for instance here, safe value just says if I have a double quote inside of a string, if I have some text data inside of my data frame, I want to make sure to escape the double quotes before I send that to the graph database, because otherwise it'll try to interpret it. So just a few little nits here and there. I'm also going to change the strings so that they're using from double quotes using single quotes is really why that. And so let me make sure to run this. Okay, good. Okay, and now for the magic. In Neo4j, there's something called an unwind. And so it's essentially doing a mini batch load. This is a really efficient way in Neo4j to be able to load a lot of records at once. So what I'm saying here is I want to be able to do a transaction with 10,000 rows at the same time, essentially introducing, you could say, some concurrency to this. So what I'm going to do then is I'm going to say unwind rows as row, and then with each one of those rows, I'm going to do a call. It will do a merge of, I've got this record type defined that I'm going to create, and for each different record, I've got a unique identifier that I'm adding. So essentially what I'm saying is insert a new record. If by any chance it had already been there, don't give me an error, just merge it with what had been there before. But keep track of these things and do it in chunks of 10,000. So I've got 100,000 records. I'll just do like 10 chunks of these. If I did not do this, I just did a transaction for every record, it would take me a couple hours. If I do this way, it'll take seconds. So doing the mini batch is a really important thing. Question?
Is it possible to change that number, 10,000?
Oh yeah. Just because of what we were working with, this worked out pretty well. It won't make a lot of difference unless you make a very large change in the number. But it's just in terms of the transaction accounting that they're using. This is a faster way to load things and then index it all kind of in a mini batch.
So what happens when there's an error in one transaction?
Yeah, it'll. I believe what this will do is it'll keep track of those and show you at the end. Hopefully we don't catch that. I've been running through that before and I didn't catch it, but let's see. Just to keep me honest here. So what I'm going to do is create this method called load records that runs this unwind, and I'll be able to pass it a data frame here, and then it'll process that. So I'm going to say these all at once. I'll say load records from places of interest, and I think that this ran in a matter of seconds before. And then the others will be very quick. They're actually much smaller. Okay. Second one down, third one down. Okay, great. Okay, and so now I just ran a really simple query to say match records. I've created a kind of node that, but from 3 different data sets, they're all under records. Each of them has a unique identifier. I'm going to return a count on those unique identifiers. So it comes back and it says I have about 85,000 records that I've loaded up from these 3 data sets. Okay, good. So that is set. Okay, so we've got our data loaded. Now the next thing that we'd want to do would be here. The next thing is to run sensing. And we only have 20 minutes left in the tutorial, so I'm going to kind of shoot through this quickly. But there is a guide to launch a Linux server running sensing. There's actually a few different ways to do this, but this is one of them that I thought would be probably easy to get running with. So there's a quick start guide, and it shows you how to copy over a Debian. Just pull this down off of AWS. So you pull a Debian file and then do a apt install. Once you've got that, then you can do apt install with Sensing API. And it will load into your Linux box, the Sensing API, all the Python support for that. If you want to be working with some other flavor than Ubuntu and Debian, if you want to be working with a different flavor of Linux, there are also images for that. I can show you those, but it has pointed here for Red Hat and Debian. Once you have this installed, then run through, well, okay, here's the different distributions. Then we'll cut back over to the slides. Okay. Once you've got it installed, there may be a problem depending on the flavor of Linux you've got and also the version, but sometimes there's a requirement for libSSL. And so if you need to, if that had not been bundled by your package manager, you can just do an explicit install of libSSL. There's actually some questions and answers about this on Stack Overflow, but just in general, in terms of Linux maintenance, do a wget to pull down the Debian for libSSL and do a dpackage. And so once you've got that, then you should be able to do the apt install Sensing API. And from there, be able to get into, it'll create a demo directory called ~sensing under your home directory. And from there, we'll have everything for what we're working with. We only have 20 minutes left, so I'm actually going to cut back over and show this running on a different server, just because I don't think we have time to run through everything. So let me load up Sensing. I'll load into one that I'd run previously. And this is probably pretty small, so just the font. For what it's worth, I'm running on Google Cloud Platform, but this would be fine in AWS or Azure or any other kind of cloud provider. It's just really vanilla Linux is set up. And hopefully we get some connection here on Google pretty soon. Is anybody running locally on a Linux laptop? What's going on? Try again. Okay, let me start this one.
Good question.
Yeah.
If you would allocate double the memory, would it run twice as fast?
No, I mean, you can get that with the threading. That's what I wanted to show is it'll do multi-threading on loads. So you can run faster if you add more threading to it. But the memory is just more, it would run out of memory space if you don't have enough. Okay. This might work better. What's going on here? Should be started. Huh. That's interesting. It says the instance is started, but it shows me being suspended. I don't understand. Well, if not, I've got screen captures. I can show all this. This is not a Sensing problem. This is a Google Cloud Platform problem. So my apologies on that. But let me cut back over and make some sense out of this here while that's loading. In Sensing, the base libraries are C++. It's open source. You can grab that off GitHub. We've got the links in the library there. There's a Python binding over the top of C++, so most of what we'll do will run out of Python. And there is a demo project, just kind of a sample application they provide. It's called G2. And so I'm going to show what I show in the article. What I was going to show here is once you install Sensing, you get a directory, a home directory, tilde Sensing. Under there, it already has Python set up. There's a directory, subdirectory called Python. If you go into it, there is a GS2 setup config. There's a small Python script which will handle all of your configuration. And in the interest of time, I'm just going to scoot through that. What I'm recommending here is, since we've already downloaded data onto your laptop, if you can bounce it through a storage grid, like GCS or S3 or whatever, that's probably best. But basically, I created a bucket that had my LV data. So I had these 3 JSON files as well, POI, DOL, PPP, and I could bounce those into the Linux server. And then you can run, there's a configuration tool. There's a very simple piece of Python. It'll go through and just add these 3 data sources. So I've got SafeGraph, Wizard, and PPP. And we give it 2 lines of configuration there. We do a template add and a generic threshold, but you can copy paste these off the slides. Once you run that, then it will be ready to consume from those local data sets that you've got. So we would just throw in 3 commands. We would say G2 loader and tell it the location for the file and give it a -NT16. That tells it to use up to 16 threads to parallelize it. So it'll run through, chunk through all these different data sets, bring them in, and do the entity resolution. Once you've got that, then it's very simple to export. You can just hit G2 export.py and give it capf JSON format, and then tell it where you want to export to, and that'll create a file. And again, you can transfer that through like the cloud storage. I have, if Google Cloud Platform is not cooperating, but I try to foresee this. So I have here under cloud storage. Oh, forgive me, I probably have some things in here. Oh, that's KG Lab. Sending. No, you know what? I will show ERTJ. There we go. So I've got a bucket here that's called ERKG. It's actually public. And under it, there's a directory called Las Vegas. And inside there's something called export JSON. So in the interest of time, back on the slides, there's a link for this. If as is happening right here, if you just hit storage.googleapis.com, ERKG, Las Vegas, export JSON, then you end up with this file. I'll download it, I'll bring it over here, copy it from source ERKG and export. So the results that come out of this are, again, it's going to be a text file. It's got 1 JSON record per line. So it's a JSON dictionary per line, but it's going to show you that you've got resolved entities. Here's entity number 1. And then this is linked with various records. So there's a SafeGraph record, ZZY, et cetera, on and on and on. And for each one of the records, it'll give you supporting information about why it made a decision, why there was a decision made to match. If there were some kind of extenuating circumstances for why the match happened, it'll show up under a match key. It'll give you a little bit of metadata. It'll tell you a match level as far as what we think the strength is for it. And then it just goes through with if there are any related entities, that is other types of entities that have been defined, but this one appears to have some overlap with. They're not strong enough to say that they're the same, but we should look at them. These will be called related entities. And so it'll have, again, a list of dictionaries for each one of those. With each one of those, it'll have the ID and again, the kind of strength and why there was some sort of match made. So in this case here, there's a related entity because of the geolocation and the name. On and on and on. So we end up getting basically 100,000 of these, or 80,000, however that worked out. But these are the results that come out. And let me check back one more time with GCP. And I'm still not getting logged into GCP. So my apologies on that, but we can move forward. Okay. Okay. I'm going to assume that we got through all of this with your Linux server, your cloud server, and just pick up from that point. Once you've got your exported entities, let's bring them in and create a graph. So let's show working with that. I'm going to cut back over to Jupyter. I've got a notebook here called Graph. And again, I'm going to clear it out and then work through. We'll do our loads, check the watermark. And now we're going to define a data class for something called an entity. This is basically where we're going to parse what's been exported out of Senzing. So all the JSON that I was just showing, I'm going to have a Python data class to be able to represent it. It's just for me be able to manage it inside the notebook and make sense out of it. And then we can load in this export.json file, set up a path for it, and just read it line by line. Each line will load as a dictionary. And we'll make sure that we parse out of there what its entity ID was. And we'll construct a local data class just to be able to wrap that. So as I run through, should be pretty quick. Okay, great. And now let's take a look at some of these here. Let's determine which ones actually have some sort of reference. So we'll add another field that says some other entity is referencing you. Should keep track of that. Okay, so if we take a look at, for instance, here's just one of the entity records that we built up. You can see it's got an entity ID and it has records it's linked to. Here's the PPP data it was linked to, Boyack and Associates. Here is SafeGraph data it was linked to, best of address, et cetera, et cetera. Okay. And that's the same thing as a data class. Okay, now over here, we'll connect up to, using our credentials, we're connected back up to Neo4j. And we'll, again, drop and recreate a constraint called entity node key. For every entity, we're going to have a node in the graph, and we want that to be unique. So we'll ask Neo4j to add that constraint and be able to guarantee it. It'll throw an error if we try to violate that. Okay, so now what we're going to do is build up a data frame based off of all the entities that we parsed, and similarly run an unwind query to be able to load them into Neo4j. Okay, boom. And so, like I say, 100,000 that was loaded in about 6 seconds. Now what I'm going to go through is take a look, and for each entity, take a look at the records that it's linked to, and some metadata about why the decision was made to link it to that particular record. So we'll build this up we'll build a data frame based off of that information. Should be pretty quick. I think it took like 7 seconds. Okay, and let's see, now we'll do this for each. Now we're going to take a look and build up another data frame about entities that were related to each other, but we don't have enough information to say that they're the same. We might want to check on them later. We'll just keep track of those. Load that up. This might take longer. This is actually a lot more information. It's not completely salient to what we're trying to show here, but it would be good practice just to keep that around. There. Okay, great. And then similarly, I'll just run a really quick cipher query to count how many of these went in. And so we've got about 83,000 records. So yeah, it's telling us that we have less of these entities than we did of the data sources records, approximately 2% less. But now what we've done is we've started to create a graph, because we have from the 3 different data sources, we have all of those data records already in Neo4j. And now what we've done is to come in and add the entities over the top and then create relations to start linking those together. And so we can start to visualize that now. I'm going to cut over to another notebook that just goes into the knowledge graph work. It's called Impact. And so here also, let me clear it out. And so again, load it up, watermark, connect up to Neo. Okay, great. I'm going to create some data frames that do some special graph analytics to measure. So the first one here is I'm going to take a look at the count going from an entity to records that have been resolved. I want to understand how many of these relationships exist and be able to look at some statistics there for them. Similarly, I want to be able to look at the entities that are related to other entities. I think it's down here. I'm going to keep a few different data frames based off of these queries. So essentially, I'm running the query on Neo, and I'm bringing it back. The results are a data frame, and then I'm going to do some statistics on what comes back from those results. So the first one, again, it counts from entity out to record, and then the next one here, for sake of making this simple, I'm going to track these slightly differently, but similarly, entity out to record, and then down here from entity related to other entities. So as I run that. Okay, and now I can start to tally and get some statistics. So what this tells us then is we had 83,000 and change for total entities, about 85,000 for total records. As far as unreferenced entities, if there are any that were singletons that were just not connected to anything, there's actually 0. We don't worry about that then. But the duplication rate is important. This is 2%. So we've been able to connect up 100% of the records, and we have a 2% duplicate rate. And that's important because that's what would lead to like false positives. And now I'm just going to do some real simple descriptive analysis of these different data frames that I've built because I want to be able to analyze. Once I understand I've got a mean value of 1.02 essentially records per entity, then I can use that to visualize. So here I come out with a plot that shows, so there's like 82,000 of the entities just have one record. And then you see the histogram where it starts to go down. We've got some of these entities that link out to as many as 14 different records. The mean is here, it's like 1 plus. Basically, you're seeing this kind of distribution, though. You've got a long tail. And that's what we worry about, because this is where the errors would really come in. And so for some businesses, this could be a real big problem because they've got not just 2 duplicates, they have like 14 duplicates. Similarly, down here, we'll take a look at how many entities have other related entities. And here it's a much more steeper distribution. You've got much more of a long tail. Some of these have more than 300 of related entities that you might want to explore later. There's not enough evidence, though, to say that they're the same. Okay, and so given that I have that, I'm going to go and visualize it. And so here we're using a library called PyViz. I really love it. It's based off of viz.js, and it's a Python wrapper. But essentially what I did was to take and throw all of the records that were unconnected, the original source data that I had. Let's just take a look and visualize those first. And so you come out with this graph. It's unconnected, but it's 85,000-ish unconnected records. But now we're going to throw in the relationships as well, taking a look at entity related to entity. And also entity related to record. That was from the previous. Come on. Okay, great. And so now I can go into PyViz and show all the different types of edges, essentially, edge data. And this is going to be a bit longer. How many people are using PyViz? or anything. Anybody else? Okay, cool. It's like a Swiss Army knife for doing sort of first pass visualization. It's definitely got some limitations in terms of how much memory it chews up, but okay, this is going to chunk along because it's a much more interesting graph, but we'll get it here in a second. But essentially what this is showing then is we've got this contrast. If we just look at the raw records, they're not connected. We've got 85,000 of those. Once we start to overlay some of the entity resolution data, I'm almost, time's up. Then we start to see the knowledge graph coming out of it. Okay, we're over. I'm gonna keep this going. This will be rendered in a few seconds. Let me go ahead and stop it though. Okay, good. And what we're leading toward, let me check back. I don't know what's going on with the GCP. Yeah, okay. Almost. I think we're at time. Yeah, okay, so we're at 3. Give me just a couple of seconds and we'll render this and we can drill down. Come on. Good. So now you can see, going back to that histogram that we'd shown before, there was a really steep head. And so there's a lot that just, they're not really connected to much. I've filtered those out because it's kind of meaningless to show. But then you can see there's this long tail. So certainly there are entities that might have 2 or 3. You can see those kind of scattered around. There's one in the center that has a whole bunch, basically. And so what we're trying to show is the contrast between these two visualizations. One of it was disconnected. We went and did the entity resolution, loaded that metadata up as edges now. And now we can start to drill in. And I want to be cognizant of data privacy for these different companies. I didn't want to necessarily embarrass or endorse anybody, but here's Mandalay Bay. And so in Las Vegas, of course, is a very big employer. There's a lot of different subsidiary businesses that they have. Here's Mandalay Corp that we have as an entity, but then here are some different types of resolutions we have out to records. Most of these are coming off of name and address, but there may be geo, there may be others. You can see one of these relationships is called initial, and so that's the seed. That's what we started out, the first record that was parsed. Everything else is sort of layered onto it. And so we're keeping track of the different types of relationships that are made. We also have some related entities that might be the same, but not entirely. Like here's a press, I don't know what that means, LMGM, et cetera. And for each one of these, we do keep a lot of the different metadata around. Just if you wanted to drill down, it's, like I say, a fairly simple knowledge graph. There's other parts I will add. I know that we're at time, but just real quick, in the article, back over here, where's my article? In the article, we also show how to use Bloom. If you've been working with Neo4j, there is a data visualization approach called Bloom. Very fast, very nice. And I wanted to be able to show it because it's a lot quicker to do the visualizations than with PyVis. But essentially going back into your database, you should be able to run a simple query up in Bloom, and it'll come down and start to give you some ability to visualize the whole thing. And then here I've done a drill down. I'm at time, so I'm not going to keep babbling, but I'll stick around if there's any questions. Thank you very much.